Hi, my name is Spencer Dunleavy. Once again, I'm a fourth-year medical student here at Columbia. In this video, you're going to learn about descriptive statistics. So in class, you're going to learn a lot about the basic statistics we use to describe a data set. This video will go over how to use R to get those simple descriptive statistics for a variable. Here, we're going to cover the following commands: table, summary, mean, and standard deviation. So for now, we're going to import the County Health Rankings dataset as we've done many times throughout these videos. I'm going to subset it to just include counties, as you've seen before. First, let's get a sense of how big our dataset is using n-row. There are 3,142 counties in our dataset. How many counties are there per state? To figure out the frequencies of certain values in a dataset, the table command is helpful. This will tell me how many rows occur for each state. So if I do table, counties df state, it'll tell me how many times each state name actually appears. When I do this, you can see Alabama has 67 counties, Alaska 29, and so on. What if you want the percent of counties in the whole data set for each state? This means you simply take the results from the table command above and divide it by the total number of counties. If I run this command, I can see that Alabama counties make up 2% of all counties in the country, compared to something like Kentucky, where it's 3.8%. Now let's take a look at some numerical data. For now, we're going to examine the rates of childhood poverty that occur in each county. So first, let's just see what these look like. As you can see, this is a lot to deal with. To be able to describe this data set, I don't want to read every single value. I want to get descriptive statistics to understand it. So we need to summarize this variable to give us more meaningful information. The summary command is often a great first step. So when I run this summary command, it's going to put out a lot of information. First, it'll tell us the minimum, which is the 0th percentile. This is the absolute lowest value that we have. Then it'll tell us the first quartile, which corresponds to the value at the 25th percentile. Then it'll tell us the median, which is the 50th percentile. It'll give us the average, which is the sum of all of the values divided by the total number of values. It'll give us the third quartile, which is the 75th percentile. It'll also give us the maximum, which is the 100th percentile. As you may remember from another video, the county with the highest child poverty rate is in South Dakota, whereas over 60% of child poverty. As you can see, summary also describes the number of missing data points we have. There's only one county in the entire country for which we don't have child poverty information. So you can actually store this summary as an object and extract information directly from it. So instead of just printing it out by running the command, I store the output in a variable called mySummary. If I want to pull out information from it, I just need to specify which part I want to pull out. Here you can see that the mean is 1, 2, 3, 4. It's the fourth index in this vector. And so if I want to pull out the mean, I can do just that. Here you can see that I pull out a little bit more precise information. In this representation, it was just rounded, but the actual value is a little bit more careful. Sometimes we want to just know the mean, so we can just use the mean function directly, as I've shown in previous videos. So I'm going to run this command, mean of this variable that we care about. What just happened? We just printed out an NA, which means there was some sort of error in calculating the mean of our data set. Well, we know we have missing data. There was one missing value in our vector, and this threw off the whole thing. So, as I mentioned in an earlier video, whenever you have missing data, you need to use the na.rm parameter to exclude that information. But this could make the interpretation trickier. Does our mean actually represent the true average of all counties in the US? Does missing just one county make a difference? I would venture to say that with 3,000 observations and only missing one, that this mean is probably fairly representative of the childhood poverty across counties. This is also quite concerning. The average child poverty rate across the country at the county level is nearly 20%. Now, we may also be interested in measures of spread of a data set. Usually, we report the standard deviation. This will be discussed further in class, both how it's calculated and when you should use this value. To calculate standard deviation, use the SD command, which also has an na.rm parameter. Just like the mean, the standard deviation can be influenced and biased if your distribution is weirdly shaped, or if it has lots of outliers. Standard deviation is a great measure if it looks like a bell curve or normal distribution. Here, the standard deviation of the childhood poverty rates at the county level is 8.5. You can also calculate the interquartile range as the difference between the 75th percentile and the 25th percentile, which is often a better measure of spread when you have lots of outliers or weird distributions. So here I can run the summary command and then see that the third quartile is 25 and the first quartile is 13.6. So I define my interquartile range as the difference between those two, and then I can print it out. And this tells me the interquartile range is 11.4. The hist command can give us a decent idea of if the data looks normally distributed. So let's take a look at the distribution of the percent of children in poverty at the county level. You can see this isn't perfectly normal, but it looks pretty good. There's definitely this long tail out to the extremes where there's high poverty rates. That may be a little bit of a skew that could influence our data, but it's really not that bad. Investigating if a distribution is normally distributed is a bit beyond the scope of this class, but it's always crucial to assess if you're going to report mean or standard deviation, dual linear regression, and many other tests that are called parametric tests. So this is what a good normal distribution would look like for all counties with the same mean and standard deviation. So here I'm creating a fake data set where I've defined the mean to be equal to the mean we found and a standard deviation to look like the standard deviation of the actual county data we found. So you don't have to worry about how I create this using this rnorm function. But as you can see, this is what a perfectly normal distribution would look like with thousands and thousands of points. It looks a little bit less skewed than something like this. So now it's your turn. Import the county health rankings dataset, and as usual, create a counties only data frame using the code below. Then you're going to calculate the descriptive statistics, including the range, mean, and standard deviation for the following variables: the percent of people in fair or poor health, the number of dentists, and the percent of people vaccinated against pneumococcus, which is the most common bacterial cause of pneumonia. For each of these variables, decide if you think the missingness might affect your data and interpretation. You can look at the histogram to see if it would be more appropriate to say mean or standard deviation, or median/interquartile range, based on if the data looks approximately normally distributed.